When we start to think about electrons being gained or lost or exchanged, right? Um, we need to look at these shells because we need to know where the electrons are coming from or where they're going. So ions are atoms with an electrical charge. Normally, our elements, right, are neutral. The protons equal the electrons, so they cancel each other out. But if you give something like oxygen more electrons, you have an unbalanced amount of electrical charge. So in this case, you have two extra electrons, and oxygen becomes -2, right? It has a -2 electrical charge. So atoms become ions by losing or gaining electrons. And the reason they do this is to achieve a full outer shell of electrons. So right here, this is elemental, right? Oxygen atom has 8 electrons, but it could have 2 more in this outer shell. And it will ionize, it will take electrons from other places to fill up this shell, right? And become this -2 ion. So oxygen will pretty much always ionize in this way. It will always take 2 electrons to fill up this outer shell. It won't give up electrons, it will take them. Because having this full outer shell um, is also like an energetic low point for this um, atom, right? So it would much prefer to have 2 extra electrons than to give up any of its electrons. The outer shell being full is like a somewhat stable state for this thing to be in. So if we look at something like sodium, right? It wants to have a full outer shell. That's what it's trying to accomplish when it ionizes. So when sodium ionizes, it will give up its 1 electron, because it only has 1 on the outside, which will then give it a full outer shell, right? Because it will no longer have that third shell. So sodium pretty much always will become a +1 when it ionizes, because it gives up this electron. So if you're wondering how something is going to ionize, is it going to take electrons? Is it going to give them away? How many? It will pretty much always follow these rules. It wants an outer shell that's full, which usually means 8 electrons. So if it only has 1 or 2 or 3, it will give those up to get an outer shell of 8. If it has 5 or 6 or 7, it will take electrons to fill that up, right? Because having an outer shell that's full is an energetic low point, right? Low in energy, which is what these atoms want to be in. So a calcium atom has 20 electrons, electron configuration 2882. Calcium ion, Ca2 plus, has 18 electrons. So we can, even just looking at this electron configuration, right, we can see that there are 2 electrons here. To get to that full 8 outer shell, it can give these up, right, and then it will have a new configuration with 8 being the full outer shell, and then it will have a relative charge of +2. Something like this, right? Giving up these 2 outer electrons. The periodic table is ordered in a very special way, right? It's an ordered arrangement of the chemical elements in rows and columns. It's really important that you know how to look at the periodic table and glean the information that is on it, right? So the position of each element actually tells you a lot of things, including the electron configuration of that element. So the groups are the numbers up at the top, right? So there are group numbers here: 1, 2, 3, 4, 5, 6, 7, 8. You might ask, why are there not group numbers down here? There are, but these elements are a little bit trickier, right? They're not within the first 20. So their electron configurations are a little bit more complex, so we're not going to worry about them yet. But let's just focus on these 8 groups, right? The groups are going down like this, so everything in this column here is in group 1, everything in this column here is in group 2, group 3, right, group 8. And these groups have names too. So, like, group 8 is called the noble gases. And they are called noble because they have a full outer shell, which means they do not want to react with anything. They don't want to give up, take, or share their electrons. They are very content to be what they are. The number of outer shell electrons is equal to the group number in groups 1 through 8. So anything in this group has 1 electron in that outermost shell. And that outer shell is really important. That's the shell that interacts with and reacts with other things. So that's the shell that we're really concerned with. The number of occupied electron shells is equal to the period number, right? So we'll go to that in just one second, but all of these elements have 2 electrons in their outer shell, right? These all have 8 except helium's an exception. Helium only has 2 in its outer shell. That's an exception to remember, right? Because this is 1 electron, 2 electrons total, so it can only have 2 in the outer shell. All of these have 6, right? All of these have 5. So this number tells you the amount of electrons in the outer shell for these. The period number tells you the number of occupied electron shells. So hydrogen and helium have 1 shell. Lithium, carbon, oxygen have 2 shells. Sodium, silicon, sulfur all have 3. So this tells you the amount of shells. The group number, right, numbered 1 through 8, we saw that equal to the number of electrons in the outer shell. And here's an example, right? Aluminum is in group 3, and it has 3 electrons in its outer shell. We can see that here, 1, 2, 3. Potassium is in group 1, and it has 1 electron. Yeah, noble gases, important group, full outer shell. So a lot of elements are losing or gaining electrons to emulate the shell of noble gases. Here's some more examples, right? So noble gases have full outer shell. Helium's our exception. It doesn't have 8. It only has 2, right? But that is its full shell because that first shell can only hold 2. Argon has 8 in its third shell, right? It's full. There's potassium and aluminum again, right? So we've seen some electron shells. We've seen the periodic table. We've seen that the periodic table can tell us about the electron shells and what's in the outermost shell. The outermost shell is the most important because those are the electrons that are taken, given, shared, the ones that will react and do something in a chemical reaction. So we're really concerned about those. Now that you know that, you are gonna do some work with that information. And then I'm gonna see you next week. So have a great day. Bye.